This is the Electrolysis Required Practical. Now, what I'm going to be doing is, during this, I'm going to be investigating or talking about how we investigate what happens when two different aqueous solutions are electrolyzed using inert electrodes. Excuse me. Now, firstly, the equipment. Now, what I've put up here is I've just kind of gone on Google and found kind of an example of what sort of basic electrolysis equipment looks like. And what we'll have is we'll have copper 2 chloride solution, right? That is this blue liquid here. The second experiment that we'll do, right, is sodium chloride solution. We've got 2 carbon electrodes. We've got 2 crocodile clips. We've got a power supply, we've got blue litmus paper, and we've got forceps. Now the blue litmus paper is all to do with kind of the test of the gas at the end. Now, it's all very good having the kind of the equipment that then is set up over there, right? But this is then kind of the diagram that you're more likely to get in some form of exam. You've got your power supply at the top, you've got your anode, and you've got your cathode. Now the way to remember those is panic. Positive anode, negative is cathode. And in here we've then got our copper 2 chloride solution. And what we do then is we pass electricity right through the liquid, the copper 2 chloride solution. And the whole point in this is to work out and actually observe what is given off. Right, so the method. Pour copper 2 chloride solution into the beaker, right? So that is this, and it's all blue. Attach the crocodile leads to the rods, that is here. Select 4 volts on the power pack and switch it on. Look at both electrodes and record your initial observations. Right, now this is then where GCSE questions sometimes catch you out. What they've done there is they've said, what are your initial observations, or what are your observations? They're not asking you what you actually know is made. What they're doing there is they're asking you what you see. All right, so you've then got to write down, I see this, bubbles, right? I see this, a coloured metal or whatever it is that's appearing. Now, if you're going to add in there what the gas is and what the metal is, then that's good, right? But you've got to make sure that you're making it clear it is what you see. All right, so use forceps to hold a piece of blue litmus paper in the solution next to the anode, which is this one here. All right, and identify the element. Then we repeat with sodium chloride, and what I'm going to do is I'm going to go through exactly the same thing on the next slide. So for this one, right, my observations are I will see kind of a light orange kind of colour that appears here. That is our copper. On this one here, what I'll then do is I'll do it kind of like a goldy colour. I will see bubbles. More green, I suppose, right? Greeny yellow. Now you probably won't actually see the greeny yellow, right? But what you'll do is you'll smell it, right? And you'll smell chlorine getting given off. And your blue litmus paper will be bleached, telling you that it's actually chlorine that is then getting given off there. All right. So that is then the sort of the methods and kind of your observations and your results for copper 2 chloride solution when you electrolyse it. Right, now what I'm going to do now is I'm just going to go through kind of the more the sciencey part of it, right? Because we've got copper 2 chloride, what we can do is you've got to think about what ions are made. So I've got copper 2 plus. Now I know it's copper 2 plus, right, because it's copper 2 and metals form a positive charge. I also know that because it's chloride, I am going to get Cl minus ions created. Now that is our copper 2 chloride, but because it is a solution, I also know that I'm going to get H plus ions provided, and I'm also going to get OH minus ions. And so what will happen then is, in our liquid, we've got copper 2 plus ions, and we've got H plus ions. We've got Cl minus ions, and we've got OH minus ions. Right, so they're the ions. Firstly, looking at the cathode, right? Now remember, it's the negative, so remember your panic. So you then know which electrode is which. To the negative cathode, the two positive ions are going to get attracted. So that is then our copper 2 plus and our H plus. And the biggest part of it is actually understanding and deciding which one is actually going to appear on the cathode. And it is always the least reactive, right, going towards the cathode. Now, I've got my reactivity series here. I've got it bigger on the next slide. So what you can do here is you can see you've got hydrogen and you've got copper. Because copper is lower down on the reactivity, it is copper that actually appears on the negative electrode. On the other electrode, right, if I just do it in, what colour shall I do it in? I'll do it in green, right? We've got Cl minus and we've got OH minus that are attracted. If there are halides, which is group 7, they are always given off at the anode. So the Cl minus will get given off at the anode. OH minuses are pretty much never ever given off because the actual chemistry behind they're turning an OH into a gas of some sort, right, is much more complicated. So for this experiment, we can see that Cl minus is given off, which is your chlorine gas that you test with litmus paper, and we've got copper that is then given off, right, which is our metal that then appears on the electrode. Right, so this is then our reactivity series. So what I then just talked about, I just talked about these two, right, going towards the negative electrode, right? Panic, negative is cathode, cathode. Copper is given off because it's the least reactive. Now, the next reaction is we've got sodium chloride. So the method itself is exactly the same, except we have sodium chloride solution in there instead. Your observations this time is you will see hydrogen getting given off and you will also see chlorine getting given off. Now the explanation behind that. This time we've got sodium chloride solution. So my positives, I've got Na plus, and because it's a solution, I've got H plus. Over on the other side, I've got Cl minus, which is the chlorine, and then I've also got OH minus. These two, the sodium and the hydrogen, are attracted to the negative cathode, and the chlorine and the OH are then attracted to the positive anode because opposites attract. The question then is what is given off, all right? And what you will do is you will see bubbles. So that is then your observation. Now that kind of tells you what is actually getting given off anyway, but if you think about the reactivity series, we've got hydrogen there and we've got sodium there, and it's always the least reactive that is given off. So hydrogen is then given off and you see it as bubbles. On the other side, it's the same as the other one, right, where halides from group 7 are always given off, so I'm then going to see bubbles of chlorine getting given off at that electrode. Now, the final one is then when I've got molten sodium chloride. Right, so if I've got molten sodium chloride, I've then got only Na plus and I've got only Cl minus. And because of that, my sodium, positive sodiums, are attracted to cathode and they are given off. And my negative chlorides are then also attracted to the anode and they are given off. Now, what I've done then is I've then gone through the electrolysis. Now, the two slides that have then got the methods and kind of a very basic diagram is the minimum that then you need to know. You also then need to know is which ion goes to which electrode. Right? Think about what becomes positive, think about what comes negative. For the positive side, it is the least reactive that is then given off. Now, the only bit in this electrolysis that I haven't talked about, right, is half equations. Now, if you are doing the higher paper or you're doing the triple paper, you then need to also look at what half equations are for the electrolysis process that I've then just talked about.
So now you've watched the required practicals. Now what you've got is instructions about what you have to do. If you're unsure about anything to do with the video, then you need to go back through it. In the exercise books, don't write out the questions themselves. For shorter answers, just write out the answers that you're using in the question, Longer answers, do a plan, make sure you get the right order, and then bullet point or small, precise paragraphs. Don't do long reams of writing, it's not the way to do it. The questions are then on the next slide. Pause the video, and when you've written the questions, review and see if it all makes sense.